Welcome to AI for GIs. Introduction to Artificial Intelligence in Class 4. AI Capabilities. What can it actually do? ChatGPT writes briefing notes. Gemini analyzes satellite imagery. Claude reviews contracts. But what are these systems actually doing? Understanding AI capabilities means knowing both what works remarkably well and what fails catastrophically. This class examines 4 core AI capability categories: pattern recognition, natural language processing, predictive analytics, and generative AI, then identifies the specific failure modes that occur when military professionals misunderstand what AI can and cannot do. By the end, you will know how to match AI capabilities to appropriate military tasks while avoiding the overconfidence that leads to mission failure. I'm Dr. T. Justin Webb. Let's begin. What keeps military leaders up at night? Operators treating AI outputs as authoritative rather than advisory. Most are doing exactly that right now. This causes mission failure. Military professionals must develop objective understanding of AI capabilities and limitations. AI excels at statistical pattern matching but fails catastrophically in novel situations. The framework: AI as decision support tool, not decision-making authority. First, the 4 core AI capability categories: pattern recognition, natural language processing, predictive analytics, and generative AI. Second, how AI perceives and processes visual information through computer vision techniques. Third, distinguishing between tasks AI performs well versus areas where it struggles or fails. Fourth, recognizing AI limitations and failure modes that impact military decision-making contexts. Marketing claims in science fiction create dangerous, unrealistic expectations in military decision-making. Systems that claim to see or understand create false confidence in capabilities that don't exist. Here's the reality: AI systems excel at processing vast data sets but struggle with novel situations outside their training data. The gap between what AI actually does, statistical pattern matching, and what operators believe it does, true comprehension, creates mission-critical risk. Pay attention to this. Pattern recognition can be defeated by adversarial deception techniques. Small, imperceptible changes that humans wouldn't notice can fool AI into misclassifying a rifle as a helicopter. Natural language processing generates fluent text that sounds authoritative while being factually incorrect. Perfect grammar, confident tone, complete fabrication. This is where leaders make fatal mistakes. Understanding both capabilities and limitations is essential to prevent overconfidence and mission failure. 4 core capabilities: pattern recognition, identify regularities in data applied to images, audio, sensor data. Natural language processing, read, write, and interpret human language for translation and summarization. Predictive analytics, use historical data to forecast future outcomes in logistics and maintenance. Generative AI, produce new content including text, images, and code for decision support. Each capability has corresponding failure modes. Let's examine them. 2012. Everything changes with AlexNet. Image classification error drops from 26% to 15%. That's an 11 percentage point improvement in a single leap. This marked the beginning of the modern AI era and triggered massive investment in neural networks. Within 2 years, every major tech company pivoted to deep learning. The mechanism: computer vision processes images through layers detecting progressively complex features. First layer identifies edges. Second layer combines edges into basic shapes. Third layer assembles shapes into whole objects. Each layer builds understanding from the previous one. Military applications today: AI scans vast satellite imagery databases, processing thousands of images to flag areas of interest for human analyst review. What would take weeks of manual analysis happens in hours. The fatal flaw: systems only recognize patterns from training data, requiring millions of labeled examples. You need massive data sets to train these systems: novel objects, unusual angles, camouflage techniques not represented in the training data. The system fails catastrophically. It's pattern matching, not understanding. AI scans vast satellite imagery databases to flag areas of interest for human analysts. Image classification identifies what objects are present. Object detection locates where those objects appear in the image. Target recognition matches detected objects against known threat profiles. You're using these systems right now across intelligence operations. Operators miss this critical detail. Systems match statistical patterns without true understanding, despite operator assumptions. The AI doesn't comprehend what a tank is or why camouflage works. It recognizes pixel patterns that statistically correlate with training examples labeled tank. Failures occur with novel objects the system has never seen, unusual angles not represented in training data, or camouflage techniques that break expected patterns. The system confidently misidentifies threats or misses them entirely. For military leaders, human verification is required because AI lacks comprehension of visual content. It performs statistical pattern matching, not visual understanding. The distinction is critical. 2017. The transformer architecture changes everything about how AI processes language. The breakthrough processes text in parallel rather than sequentially. Previous models read text one word at a time, left to right, like you're reading this sentence right now. Transformers see the whole sentence at once. This enables simultaneous attention to all parts of the text, capturing long-range dependencies. The model understands that a pronoun in sentence 5 refers back to a person mentioned in sentence 1. It tracks context across entire documents. A single architecture performs translation, summarization, sentiment analysis, question answering, and generation. One model, multiple missions. Military applications right now. Intelligence document analysis processing thousands of pages to identify key information, intercepted communications translation, providing real-time linguistic support, automated report generation, creating initial drafts for staff review. This lets analysts focus on interpretation and judgment rather than rote processing tasks. Watch what happens next. The critical limitation. Current systems generate grammatically correct text but lack true understanding. These systems predict word sequences based on statistical patterns in training data. They don't comprehend the concepts they're writing about. They don't reason about whether statements are true. They generate fluent text without comprehension of meaning or reasoning about truth. They produce authoritative sounding but factually incorrect content. Perfect grammar, confident tone, professional formatting, completely wrong. The military risk. Plausible but inaccurate intelligence summaries that mischaracterize threat capabilities. Threat assessments that sound authoritative while containing fabricated details, and they sound completely convincing to operators who don't verify. Human verification is essential before incorporating NLP outputs into decision-making. Not optional, essential. Every single output requires validation against source material and ground truth. AI identifies patterns in historical data to forecast logistics requirements, equipment maintenance needs, and threat assessment outcomes. When it succeeds, physics-based predictions, ballistic trajectories, fuel consumption rates, equipment wear patterns are reliable because they follow fixed physical laws. These predictions work because physics doesn't change. When it collapses, human behavior predictions are less reliable because people exercise choice and can deviate from historical patterns. Adversaries adapt, commanders make unexpected decisions, political conditions shift. Maintenance systems work by recognizing patterns that preceded past equipment failures. When a gearbox shows vibration signatures similar to previous failures, the system predicts imminent breakdown. This works when failure modes remain consistent. Systems succeed when the future resembles the past and historical patterns remain stable. This haunts me. AI continues producing confident predictions even when underlying conditions change and predictions lack valid basis. The system doesn't recognize that its assumptions no longer hold. It doesn't know it's wrong. Foundation models trained on broad data using self-supervision at scale. The systems you're using right now, GPT-5, Claude 4, Gemini 3, Llama 4. These models learn general representations from massive datasets, then adapt to specific downstream tasks without task-specific retraining. One model serves multiple missions: military applications, briefing preparation, creating initial drafts of operation orders, course of action development, generating alternative approaches for commander consideration, document drafting, producing formatted reports following military writing standards. The correct split: AI handles information processing at speed and scale humans can't match. Humans handle judgment calls, ethical reasoning, and final decision authority. This division preserves what AI does well, while maintaining human responsibility where it matters. Don't miss this. Generated content requires verification because systems produce statistically likely outputs, not verified facts. The output sounds right. That doesn't make it right. This is where leaders fail. The framework collapses when operators treat AI outputs as authoritative rather than advisory. The failure pattern: operators receive AI-generated analysis that looks professional, sounds confident, and follows proper formatting. They assume verification already happened. They incorporate the output directly into decision briefs without validation. AI generates statistically likely outputs that may contain fabricated details, mischaracterized threats, or conclusions drawn from flawed assumptions. These outputs require verification before entering the decision-making process. Human operators retain responsibility for judgment and final decisions. The AI is a tool providing recommendations. The operator is the decision-maker accepting accountability, not the AI, you. Misunderstanding operational boundaries, where AI assistance ends and human judgment begins, creates dangerous operational risk. Look at what happens when this goes wrong. June 2009, ice crystals blocked the airspeed sensors on Air France Flight 447. The autopilot disconnected. The aircraft fell 38,000 feet into the Atlantic Ocean. 228 people killed when the crew, accustomed to automation handling flight control, could not recover from the failure. The investigation found the crew was completely surprised by the autopilot failure. They had developed such reliance on automation that they couldn't respond effectively when it stopped working. The pattern: AI failures are catastrophic rather than gradual, making them unpredictable and dangerous. Unlike humans who recognize uncertainty and communicate degrading performance, AI systems produce confident outputs until complete failure. No warning, no gradual degradation, no indication the system is struggling, just catastrophic collapse. The critical lesson: automation creates brittleness, requiring human oversight and intervention capability. You have to maintain the skills to take over when it fails. If you lose those skills through disuse, the automation becomes a single point of failure. 2023, Mata versus Avianca. Attorneys submitted an AI-generated legal brief to federal court. ChatGPT fabricated 6 non-existent case citations with realistic-looking details. Case names, court jurisdictions, judge names, legal reasoning, completely made up, never existed. The attorney later testified he was operating under a false perception that AI could not possibly be fabricating cases. He trusted the technology beyond its capabilities. The attorneys were sanctioned by the federal court for failing to verify AI-generated content before submission. The court made clear, using AI doesn't excuse you from verification responsibilities. AI generated authoritative sounding but completely fabricated legal precedents. They looked real. Proper citation format. They sounded real. Legal reasoning that seemed plausible. They were fake. Every single one. This demonstrates the critical need for verification before incorporating AI outputs into decisions. Every single time. No exceptions. Operation Iraqi Freedom. 2003. Patriot air defense systems shot down 2 friendly aircraft, a British Tornado and a Navy F-18 Hornet. A researcher with 35 years of Patriot system experience studied these incidents and reached a damning conclusion. An automated system in the hands of an inadequately trained crew becomes a fully automated system in practice. The crews trusted the system's classification without knowing that a flaw in the program led them to the wrong conclusion. They saw the automated recommendation and executed it with no outside communications or backup systems to verify the target. The system indicated a threat. Given the combat environment they had experienced days prior, they believed it. The National Institute of Standards and Technology identified AI bias falling into three major categories affecting military decision accuracy: systemic bias in datasets and development processes, computational bias from non-representative data samples, and human cognitive bias in how operators perceive and use AI outputs. The recurring failure: automation creates over-reliance when operators lack understanding of system limitations. They don't know when to trust the system and when to question it. Human oversight is essential, but requires adequate training on operational boundaries. You can't oversee what you don't understand. If you don't know how the system fails, you can't catch the failures. Bottom line, AI excels at processing information through statistical pattern matching at scale, thousands of satellite images analyzed in hours, intercepted communications translated in real time, historical data patterns identified across massive datasets. That's what it does well. Systems fail catastrophically in novel situations not represented in training data. No warning signs, no gradual performance degradation, just catastrophic failure when conditions shift outside training parameters. AI outputs are advisory and require human verification before entering decisions. Every intelligence summary, every threat assessment, every predictive forecast, every time. Operators must understand operational boundaries to prevent dangerous misapplication. Know when AI recommendations are reliable and when they're suspect. Recognize the conditions where the system operates outside its design envelope. Human judgment, ethical reasoning, and final decision authority remain essential and non-delegable. The AI is a tool providing decision support. You're the leader accepting accountability for the decision, not the system, you. Now you know the capabilities. Next question, which tools should you actually use? Class 5 covers AI platforms and tools. We'll explore the major commercial platforms, evaluate their strengths and weaknesses, and learn how to choose the right tool for military applications. Stay connected with AI for GIs on TikTok, Instagram, YouTube, or LinkedIn. Visit the full course in the link below. I'm Dr. T. Justin Webb. Thanks for joining me for AI for GIs.